Hello everyone, welcome to the lesson 5, the last lesson that will be assessed in your exam from the chapter 2, that is limits involving infinity and asymptotes. We will look into the learning objectives. They are to find infinite limits and limits at infinity, to find horizontal, vertical and slant asymptotes using limits. So we'll look into both of these objectives in this video. Before we begin, the keywords of this lesson are finite limit, limit at infinity, vertical asymptote, horizontal asymptote, slant asymptote. So we will come across all of this. Now, the first thing, it's a simple problem what we have done in the previous lessons. Before I continue, I just want to recall that we can do all these problems in the shortcut method, which I've already discussed in the previous lessons. I will show it again. So you can just use that method and solve this entire lesson. It will be very, very easy. So the limits part can always be done like that, and it will be very simple and very easy. But I will also explain what each problem means and how you can solve in the proper method and also the shortcut method. Now this one over here, we have already done it before. Now here I will just, you can go back to the previous lesson. The same problem was done. So basically, if you see the graph, it's a rational function. It will be like this. There is no values at 0. Why? If you try it in your calculator, 1 divided by 0 is undefined. Now here, what we can do is put x, say alpha x, write this equation as it is and calculate x. Not at 0, at values close to 0. Instead of 0, we will do minus 0.01 and 0.01. This is positive. So we will do that, minus 0.01 and see what's the answer, 100. You can increase the zeros, negative 0.0001. This means it's very, very close to x value, very close, to 0 value. Now here you're getting a big number. That means it's increasing, it's decreasing because it's negative. It'll go up till negative infinity. Now same thing, we can calculate this value at 0.00001 and you will get a big number, that is positive infinity. What it basically says is, you can do this table as well, we have done in the previous lessons. The limit at 0 from the positive side, from the right side, okay, limit is not giving you the value at 0 but at close to 0, what it means to be very near 0. So over here, when we come from the right side, you can see it's positive infinity. You can see the graph, it's just going up, and from the left side it's negative infinity, it's going down. So that is the answer. We have done this before. Now here you can see there is a vertical asymptote, isn't it? See, this is the asymptote. It doesn't come, over here you cannot have 0. These lines are very, very close to 0 but not touching 0. So that is an asymptote. Asymptote is a line where the values will tend towards it, but it will not be equal to that point. So that is the thing. Now here then, same problem, but we have a x square. What happens with square? Whenever you have even power, if it's square or to the power 4 or 6, 8, 10, what happens? Let's just see it. Imagine you have a negative value. Square it. It's going to be positive. Now, if I have a positive value, what's going to happen? It's going to be positive. So whatever value I take, it's just going to be, if you have thought in your mind positive infinity, yes, that is correct. It's going to be positive infinity because both the points are just going upwards. So now see, limit from the right side, 0 right side is also positive infinity. Left side is also positive infinity. Now here, does it exist? No, the limit does not exist. One second, let me go back over here. Here 1 by x, as x tends to 0, limit does not exist. If it's infinity, if it is, two different limits, it does not exist, right? We have done this in the previous lessons. Here also, limit does not exist. But look over here, what is written? Limit is written as infinity, right? What does that mean? See, infinity is undefined in its own way. What is infinity? You don't know the number, therefore you are writing infinity. That's undefined. So when you tell this limit as x tends to 0 for the function 1 by x squared is equal to infinity, it does not exist in its natural way because this is undefined. But just for simplicity's sake, we tell both these limits are going towards positive infinity. That means we are getting a description of the graph. It's going upside, and we write just infinity. Is that okay? So this is very important to understand. The limit does not exist when it's infinity or when there are two different numbers over here. It must be the same. But here, since the infinity are same, positive infinity and positive infinity, we just write positive infinity when these both agree on each other. But actually this does not exist because infinity is already undefined. Now for this lesson only, because we are dealing with asymptotes, just remember we write it like this. Okay. Now then, this is what it says. Now here both the sides, it's coming to the same point, but it's infinity. Now let us look over here. Now if you think what's going to happen at phi over here, when phi is there, it's going to be 0, right? Look at the power, it's odd. When it is odd, your even if it's negative or positive, it will remain as it is. Now what I'm trying to say is, if it was even power, both negative values and positive values were positive itself. But now if I make it power 3, it's going to remain negative, and if it is positive, it's going to be positive. So here, even without solving it, you can tell the limit does not exist. Why? Because at one side it will be positive infinity when this is greater than phi, positive. See this x phi plus, that means from right side when you're coming, it'll be 5.001, that will make this positive. Both the sides will be positive. Whereas if you're coming from left side, it will be 4.99, it will be negative and it will remain negative. So it will be infinity in both the cases, but plus or minus changes. So it does not exist. Now if you're thinking, what is this plus plus? Now here what's the sign? It's positive itself. Now here apply phi from the right side. It'll be 5.1 or 5.01. What's going to happen? 5.01 minus 5 would be positive number. So we write plus here. Both the side it's plus, so infinity will be plus. Here upside is plus. What will happen over here? Negative means it'll be 4.999. There will be negative 0.1. It will be minus down below. So you will have minus. So it's plus infinity minus infinity. It does not exist. Since the one-sided limits are different, one-sided in the sense this plus and minus, this is one-sided limit. If they match, only then we write it same. If it was both minus infinity, it doesn't exist, but we write it as minus infinity. Here, another case where infinite one-sided limit disagree. Now this is another case. You can see minus 2. Here it's fine, here it's fine. Here when you apply minus 2, this becomes 0. So we need to do limits. Over here you can see directly, you can how you can solve it directly is, one way is the calculator method. Let me do it first, the calculator method. For such problems, the direct method, if you solve it, it's easier than the calculator method, but I'll show you the calculator method. Just type x as it is, write that equation altogether. Plus 1 divided by alpha x minus 3, close the bracket, and then over here it will be alpha x plus 2. Okay, now calculate x at what? It's negative 2, isn't it? The value, the limit. So you should take negative 2.01 and negative 1.99, because these are the values which is very, very close to negative 2. Now what? Just type this, negative 2.0001. You can add this, or you can just, however, let me take this only because I've written over here. What's the answer? It's negative 20. But let's just see, if I increase the zeros, I made 3 zeros, it's going to be 2000, and it's increasing. So, when the numbers are not accurate, it's not like 4.99 or something like that, then just increase the values of zeros, make it very close to the given limit, and then check. Now here we can understand this, when from left side it's going to negative infinity, over here it's minus infinity. Let me do the right side. All I need to do is calc at negative 1.9999. What's the answer? It's positive infinity. This is the answer, so it does not exist. You can directly write it. Another way would be, since this is, see, this is having three separate terms, just substitute minus 2 over here. Substitute minus 2, and sorry, you can substitute minus over here. You can't substitute. You should substitute this over here, minus 2.01. Okay. For the first two terms, it doesn't make a difference. Last term, yes, it will make a difference, minus 0.1. What happens? If it's negative 2.01 plus 1, it will be negative at the top. Here, it will remain negative only. Negative, negative will be negative. And what happens over here? It will also be negative. So, oh, what's happening? Okay, it's the second time. I better back up my laptop before it crashes, you know. So, over here, what happens is, you can see there is negative 2.0, over here it's negative, negative, negative. Multiply the negative signs. Negative, negative means positive, and over here negative, ultimately you will have minus. Okay, so if I take this side, one-sided limit from x as it tends to minus 2 from the negative side, you can see it is minus infinity. Let's see over here, this one. You can see all the three terms will be negative. I hope this is clear. Now, if you take negative 1.99, over here it doesn't make a difference in the first two terms. Only the last term it will make a difference. So let's take 1.99. Here it will be minus itself. Even over here it will be minus itself. 99. But this one, negative 1.99, what happens? Positive 2 is greater, so it will be plus. So minus and minus will become plus, plus and plus is plus. So you will have positive infinity over here in this case. So this is how we solve it over here. You can see the minus, minus, minus. When we are coming from the right side, it is negative 2.01. So when we come to the right side, positive side, it is negative 1.99. Because negative 1.99 is greater than negative 2.01. Okay, so therefore it is infinity. Why? Because this becomes positive and you're having positive infinity. Whereas over here there were three negative signs. Negative, negative, negative. 2 makes positive, plus and minus makes minus. So therefore we will have negative infinity. I hope this is clear. If you're still getting confused with this, just do the calculator method which we have learned in the previous lessons and which I showed you at the beginning. Before explaining this, you will get the answer. So you can see it does not exist, but you can tell that. See, what happens is one side it is going positive infinity, right, from the right side, and left side it's going negative infinity. What's happening? There is a vertical asymptote, isn't it? You can see there's a vertical asymptote, the straight line. See, there's a straight line. That's what. If it was going like this and like this, we will see now. You will also come to know over here that will be a horizontal asymptote, which we'll see now, I guess. No, in some time. Before going ahead, we will see a trigonometric function. You know, tan x is a trigonometric function, and the graph will always have asymptote at every pi. At every pi there will be a asymptote. Sorry, not at every pi. It's at pi by 2. Yeah, it's at pi. Sorry. Oh yeah, pi radians. Now, anyways, they have asked us to find at the limit pi by 2. So, what happens? How do you do? Don't worry, just do it in calculator if you're getting this all confused. Take the calculator, make the mode to radians, shift mode and 4. This will give you radian mode R. If it is already there, it's fine. If you're clearing your calculator, it gets back to degree mode. So press shift mode and 4, get into radian mode. Now type this as it is, tan alpha x, close the bracket. Now this is important. Pi by 2 means 1.571 or something like this. Okay, so what you can try is calc pi by 2. Directly press shift and pi divided by 2. Divided by 2. You will not get any answer. Why? Because it's infinite over there. It's undefined. Now what you can do is, if you press calc, it'll show you the exact one. It's 5.707. Okay, this is the thing. Okay, let me write it over here, 07. Now let's get values less than this and greater than this. So if I'm going from pi minus, what value should I put? I should put over here 1.570, less than 7 would be 6. If I'm going with the limit pi by 2 as positive, all I need to use x as 1.570. Instead of 7, more than that will be 8. That is it. So pi by 2 is 1.5707 and it goes on. So all you need to do is just change one decimal. 57, don't change over here. You will not get more accurate answer. You can change this over here. You can keep it 0 and 1, or you can change this. Now let's try. Let's go back. That's okay. Tan x, calculate x at 1.506. And what's the answer? It's 15. Now, if you make this a bit more, oh, sorry, that was wrong. Let me just write it, tan alpha x. Now, if you make this instead of 1.506, 1.5006. Oh, sorry, I've forgotten 57. So that is the mistake, okay? 5706. Okay, you can see the number. It's very going towards infinity. It's very close to a huge number. Sorry, it's not. It's becoming a huge number. As I go very close to this number, it'll become more and more huge. That is what I wanted. Now, what about the other side? This is for the negative limit. What about the positive limit? Tan x calc at this number 1.5708. And what is the answer you're getting? It's a huge negative number. That means it's a very tiny number. So that's why here we will have negative infinity, upside we will have positive infinity. The limits does not exist. But you know it's a vertical asymptote. Why? Because it's going up and down at the same time. So you can see over here, up, left side is down. So that is the thing. So we have a vertical asymptote. Now let's see limit at infinity, mainly dealing with the horizontal asymptote. See, till now we were checking at one certain point like this, vertically, right? Like this. So up and down, right? At say 2 or 5 or 3 or 0. Now what we are doing is we are tending the limits towards infinity. See, limit x as it goes to infinity, what is happening? As it goes to minus infinity, what is happening? This is what we will learn, and now we will see horizontal asymptotes. We will deal with horizontal asymptotes now. Before that, you need to know a few things. What is 1 by 0? 1 by 0, 1 divided by 0. Okay, this is for general knowledge. It's undefined, yes, but have you ever thought about it? Division means you're arranging something in the numerator in so many groups as the denominator. Now, if I write a number, say 10 divided by 2. Imagine you have 10 chocolates, you want to divide it by 2. What does that mean? I need to get those 10 chocolates in groups of 2. That means I can do one group with 2, another one, another one, another one, another one. This is division, right? So answer is 5. That means one group, 2, 3, 4, 5. So I can divide these 10 chocolates in groups of 2 5 times. So that is the thing. If I have 10 divided by 5, I need to divide this 10 as groups of 5. I'll get 2. Answer as 2. 10 divided by 2 is 2. 10 divided by 5 is 2. Now here I have 10 chocolates again. Okay. I need to divide by 0. That means make group of 0. Okay. 0 is nothing. So I can do it one time. I can arrange. I can do it 2 times. I can do it 3 times. I can do it 100 times because it's nothing, right? How many times can you do a group of nothing? I can do it any number of times. If I want, I can do it 10 times, 20 times, infinite times. So whenever you divide anything by 0, the logical answer would be, it will be a huge answer. Okay, it's infinity. So if I write 1 by 0, the logical answer would be infinity. Same way, now take this infinity to the other side. 1 divided by a huge number would be corresponding to very small number or 0. Now this is not equal to, you can't write equal to, okay? This is always corresponding to. So here, limit x tends to infinity. Now because we're dealing with limit, we have equal to. As the limit x is going towards infinity, 1 by x will be 0. Now, to prove this, you can try in your calculator as well. 1 divided by, we can't do 0, we will take a very small number, very close to 0. It's huge number, it will go towards infinity. Now same way, we'll take 1 divided by a huge number. Let's take 999. Okay, this is a huge number. The answer is 0.000, so many zeros and 1. It's almost equal to 0. So what you can take is limit as x tends to infinity, both whether it's plus infinity or minus infinity, it's going to be towards 0. X will be, the value will be 0. Okay, whenever you have a huge number in the denominator, doesn't matter it's a positive or negative. Let's see this. Let's make this negative. It doesn't matter. See, now over here it's just showing negative sign, but 0 is neutral. It's coming towards 0, right? Doesn't matter positive or negative. It's almost 0.00. It's a 0 itself. Okay, that is the thing. Now we will see problems over here. They have asked you to find whether there are any horizontal asymptotes. If you want to find horizontal asymptotes, you must take the one-sided limits as infinity. Sorry, not one-sided limit. You should take positive infinity and negative infinity. That's it. Now, whenever you have positive infinity over here, this will become 0. So answer is 2. When you have minus infinity, also this is 0. Answer is 2. Both the sides it's 2. So what is happening? Both one side, both the limits, minus and plus, is at 2 and 2 when you take the limit. That means as you go towards right, it will tend towards the value 2. Even if you're going towards left, it's going towards 2. That means I don't know how is the asymptote. It might be down, up, anything. See, graph won't be given. This is the real graph, but you don't know the graph. You can think it's like this, but you know there is an asymptote at 2. That is it. So this is our main concept. You know there will be asymptote at 2, and that's how you solve it. I hope this is clear. All you need to do is substitute over here and take the limit of this at positive infinity and negative infinity, and then see whether the answer is same. If these both answers are same, then yes, there is a horizontal asymptote. Now we will look into these theorems. It just tells you about the powers. We have dealt with this. You know, whenever the power is odd, you will have negative infinity will make it odd, positive, everything. Even over here you're dealing with few of the things about the degrees. Now we will see a problem. Say for example this problem. Now they have asked you to find x at infinity. Now we will see practically what the theorem means. Okay, now what is this? Limit x tends to infinity. The best way would be directly substitute infinity, is it? So if you substitute infinity, you'll have positive infinity divided by infinity. What is the answer? Is it 1? Or is it 0? Or is it infinity? Or is it another way to solve it? Now guys, infinity divided by infinity is not as say 10 divided by 10. That's not equal to 10 divided by 10 is 1, but infinity can be any number. It's undefined already. You don't know the exact number. Even over here it's undefined, so you can't divide them. That is an indeterminate form. This is a wrong form. Okay, it's not this. No, it's not equal to 1. This is incorrect. Now in such case, say over here, this is the answer, graph, if we do it in graphing calculator. But how do we solve if we don't have graphing calculator? There is a thumb rule. Okay, this is the thumb rule. You can read all the other things later on. Now basically infinity by infinity is an indeterminate form. That's what they tell. Okay, now look over here. There's a thumb rule which is very important. Look at the given question. This is the question, right? 5x minus 7 divided by 4x plus 3. Wherever you come across an indeterminate form, you need to remember this one. Tell over here. Divide numerator and denominator by the highest power of x appearing in the denominator. What does it mean? You should look at the denominator. Okay, see down. Okay, this is which is the highest degree? Over here, highest power. X, this is it, x to the power 1. So you need to use this number to divide up and down. Now, sometimes some students get confused. What if there is x square? They consider, okay, x square is there, right? I should divide by x square and x square. Wrong, it's numerator. No, it's not to be from numerator. If it's a numerator, no, forget it, ignore it. You must take from the denominator. If this was x to the power 2, yes, it'll be x power 2, power 2. But that wouldn't be an indeterminate form, it's another thing. But here, when you find indeterminate forms, what you need to do, see the denominator highest power and divide. So 5x minus 7 divided by 4x plus 3, divide by x. So x cancels and you will have over here x and over here x. Okay, so what is any constant divided by x? That's 0. This is also 0. So what's remaining? 5 by 4, isn't it? Your answer is 1.25. That is where you will, so let's just go back and see. Yeah, that is where the asymptote is there. Okay, so 1.25 was the answer. Now that is how we can solve this. Now one more thing over here, what you understand is as x is going towards infinity, where is it going? Towards 1.25. You can do it as minus infinity as well, you'll get the same thing, but they have just asked you to find this limit. They have not asked you asymptote or anything, so just solve it. Now if you're doing in calculator, type this equation as it is. In calculator method, it does not change. It's the same for all the lessons, so it's very easy. If you remember in the previous lessons or the previous questions which we solved just now, we type the equation as it is and then calculate at what? At infinity. Now you don't have infinity, right? Don't worry, put a huge number over here. Let me put such a huge number. What's the answer? 1.249999. Okay, what does it mean? It means it's almost going towards infinity, right? That's it. So over here, see, since they have asked only positive infinity, just take a big number. That's it. Calc, you can increase it. If you want a big number, you can just write over here, say 15. 1 into 10 to the power 15 means 1 and 15 zeros. You can see if you take a huge number, it will automatically approximate towards 1.25. Okay, so that's the answer. Okay, now you can try this as well. All you need to do is type it up over here. Okay, 1 second, let's go back to this question over here. I will type it once quickly. 5x minus 7 divided by 4 alpha x plus 3, and now I'll calculate -1, negative big number. Okay, the answer is almost 1.25 itself. So now you know positive infinity and negative infinity are towards same, so you have a horizontal asymptote. Why I did that is next problem is different. Now let's do this problem over here. 4 alpha x to the power 3 plus 5 divided by minus 6 alpha x square minus 7 alpha x. Now let's take positive infinity, calculate a huge number. 1 into 10 to the power 10. You are getting minus 66666. So it means it's going towards negative infinity, right? So this is what it's going towards from the positive. And as we go over here, if this is the graph, as we go right side, it's going towards negative infinity. Okay, so it's going like this somewhere, negative infinity. Okay, so if you increase the numbers, you will see that it's going something like this. Why? Because as I increase the numbers, it's going more and more towards negative infinity. It's not coming towards a certain point. It's changing. So in such cases, just check, calc at the negative 1 into 10 to the power 10. What's happening now? You can see the number is positive. As we go towards left side over here, x is going, it's going like this. So here we have a horizontal asymptote. Now this is not the exact way just by looking at the limits, but looking at the equation, you can see that there is 4x power 3 and over here the difference in degree is only by 1. So in such cases, when you're taking towards infinity, remember it is going to be a horizontal asymptote. Why? It's not 1 by x. Look, Be careful, it's not 1 by x. If it was 1 by x, yes, then it would be horizontal asymptote. Now this is not horizontal asymptote. Why? The above degree is more than the denominator, but still you're getting plus and minus infinity. The limit does not exist, but if you graph it out, you will come to know this is a oblique or slant asymptote. I don't know, what did I tell at the beginning? It should be slant or oblique. Okay, that's the exact word, that asymptote. So it's something like this. I drew it, so that's the correct one. Now here you can see it will be minus infinity because it was, sorry, now this is wrong. Why? Calculate at positive infinity. Let me change this to 15. You can see it's a huge number but negative number. So minus 6 point and a huge number. So it's minus infinity. As we go towards right, it's decreasing. Now if you want to check this further to find exactly what is the asymptote, you need to do long division. Now what is long division? I hope you remember which you did in the last grade before synthetic division. It is 4x to the power 3 plus 5. And you need to divide it by minus 6x squared minus 7. Now over here, you need to divide this by this. So it will be, okay, it is 4x power 3 divided by minus 6x squared. What is the answer? It's x, and over here it is 2 by 3, minus 2 by 3. So first one will be minus 2/3 x. Now you need to multiply this, you will get this answer. Multiply minus 7 over here, it will be minus 14 by 3x. And now change the signs, this will be plus. The first one cancels, your remaining with over here, you need to add them both. You can use the calculator. And then you need to do this. And then again divide and continue. You will get one more answer over here. Since it is x and... okay, did I write it right? Okay, I wrote it wrong. Why? Because it must be 0. There is no x squared plus 0 plus 5. 5 is constant. So just remember, this is the long division. The first, yeah, this is the correct answer. And then you will directly have constant. Why? Because it's a constant over here. You will have some value. And then you will have remainder because you can't continue further. This remainder basically goes off. Why? Because it's divided by x, right? This is equal to 0. Okay, when you put infinity, you can try this, put infinity instead of x, huge number, the answer will be 0. So this remaining part is a linear, this is the linear function. That means that is the value of this slant asymptote. I mean, that is the equation of the slant asymptote. So this is about slant asymptotes. The main concept is getting this infinity and telling, you know, from this equation you can tell this is a slant asymptote. And if you want to find the asymptote equation, you need to do long division. So long division videos are there already in this channel. It'll take a long while, but just quickly you can go back and see the long division method, because many problems are there. Or you can't do synthetic division over here. Do the long division, and I will put the long division video in this you know, in the caption over here, so you can easily click on that and check the long division method as well. Okay, so this is the equation of the horizontal asymptote. Not horizontal, sorry, slant. I'm sorry for that. Okay, we are nearly there. Two limits of an exponential function. Now this is very straight. If you're getting confused, just use the calculator, because even the otherwise you should just remember the tricks. Like, I mean, you should know 1 by infinity is what, 0, and then substitute and you will get the similar thing. But since they have given you one-sided limit, you must be careful with, you know, powers, negative and positive. Whenever it's 0, less number would be negative 0.01, more would be plus 0.01, isn't it? Now what happens if I have anything to the power negative 0, I mean 0 to the power negative something? What I mean is, if I have 0 to the power anything, what's the answer? 0. But now, let me take 0 to the power 1, 0. But let me take it as negative. What's going to happen? I'll just explain why is this happening. Now take, for example, 2 to the power 2, it's 4. But let's take 2 to the power minus 2. What's happened? You can make this positive by taking it to the denominator. So it will be 2 squared. This is correct. If I have 2 to the power minus 1, it will be 1 by 2 to the power 1 or 1 by 2. Same way, if you have 0, negative 1, it will be 1 divided by 0, isn't it? This is wrong, undefined. So you can never have anything power 0. So now, here that is the concept. So you will get an infinity over here. What happens is, if you take a positive thing, 1 divided by 0. Okay, whatever I just now told is not so important for the problem. I thought it was. I think so it's important somewhere else. But anyways, what I just now told is anyways good for your knowledge purpose. Okay. Yeah, because I thought because it's powers, so that's why I explained the powers. It's not related to this thing. Over here, that doesn't matter. It just matters whether you substitute over here negative and you will get positive infinity or negative infinity, and then you solve. So basically, let's directly solve this. Shift and E, 1 divided by alpha x. Okay. Now calculate. At first one-sided limit is negative 0.0001. Okay, what's the answer? It's 0. Okay, it will tend towards 0. Why? Because over here you have negative infinity. This one, it will be negative infinity, and anything to the power so much will be 0. Okay, you will directly get in the calculator. Next one, all you need to do is calc and take towards positive 0.0001. Okay, you're getting a math error. Why? Oh, okay, now this is interesting. I think so the math error is because of, whenever I type huge number like the 0.001, your calculator cannot calculate it. So let's go with the small one, 0.1. Calc. Okay, now you're getting a huge number. So you can see for the left one-sided limit, when we just substituted calculate at negative 0.001, you got an answer that is very, very close to 0. So as you increase negative 0.001, it almost showed you 0. Whereas when you're going towards, only when you deal with Euler's number, because you're taking something to the power, it's going to be a huge, huge number. So just be very careful. So over here, calculate this 0.1 first. You can see it's a huge number. Then calculate 0.01. If you go more further, you will get an error. Why? Because that number cannot be fitted into the screen. So that's the reason. So you can see from the left-sided limit, one-sided limit from the negative part of 0, it's 0, whereas from right side it's infinity. If you're thinking why, just look at this. Here, when you take, see, this is explained over here. This is what happens. You will have negative infinity. So negative infinity makes it basically e to the power negative infinity. It basically makes it to 0. Whereas if you had positive infinity, 1 divided by 0, it'll be e to the power very, very small number. Okay, if we go back to the theorem, you'll realize in one of the page we had those things, the formula. So that is what happens, and that's why we are getting these answers. Okay, even I'm getting confused now with all these going on, but anyways, it was explained before. I believe you can just go back and you'll get it. Sorry for that. And best thing, if you're getting confused like how I'm getting confused right now with all things going on, so just do the calculator method. You will definitely get the answer. So that is the thing. So you can see the graphs over here as well. And now then, the last, not last problem, but we are nearly there. Here we have tan inverse. Don't worry, you can just use shift and tan inverse, and then instead of instead of x, put this alpha x, and then calculate at a huge number and at a small number, and you will get the answers. Let's see. Let's put a huge number starting with positive infinity. Calc, and a huge number will be like this. And it's in radian mode, so it's fine. I'm getting 1.5706. Now, if you recall, 1.57 means pi by 2. So if I just increase this to a huge number, say 10 power 10, I'm going to get it very, very close to pi by 2. But you may not get it like this. You should know 1.5707 means pi by 2 or 1.571. So now let's change this to negative. 1 into 10 to the power 10, this is a minus number. I'm getting minus pi by 2. So These are the answers. The limits for the as x tends to positive infinity and x tends to negative infinity, you get pi by 2 and minus pi by 2 respectively. So just use the calculator method and you can solve any problem in this. How about a real world problem? Now, this is an interesting one. Suppose that the diameter of an animal's pupil is given by f of x millimeter, where x is the intensity of light on the pupils. If f of x is equal to 160x to the power minus 0.4 plus 90 and 4x to the power minus 0.4 plus 15, find the diameter of the pupil with minimum light and maximum light. Okay. So now, whatever I told you a while ago, about the power, this was the one. So x to the power minus 0, or sorry, 0 to the power minus some value. Okay, minus value. Now this is what it means. This would be 1 divided by 0 to, okay, positive 1, right? So this would make sense. Now, whatever I told about that power thing a while ago, that was for this problem. Okay. Okay, so now here there are two things: minimum light, maximum light. Just in normal sense, what do you think is minimum light and maximum light? How much is minimum light? Is it minus infinity, plus infinity, or 0? Now, if you're thinking minus infinity, it is wrong. Minimum light would mean it's 0, whereas maximum light means too much light, infinity. Okay, so we have to solve this at two instances, at minus infinity, 0, and at plus infinity. Why? Because now, if you have not understood this problem, see, even in our own eyes, you can see that whenever there is less light, our eyes widen up. The pupils widen up so that we can see better. Though we don't have night vision, whenever there is less light, the pupils expand so that we can have a better look at something. Whereas if there is too much light, it's hurting our eyes, and the pupils dilate, it becomes small. So this is something you learn in biology basically. So this is the exact equation, and we are trying to find maybe there's some experiments done on a certain animal and they're trying to find the dilation effect. Now, minimum light over here would mean f of 0. Wherever x is there, just find 0. And then try to find what is happening in the, how much is the value for at that particular limit. Now here, remember, you can't have a negative one-sided limit because we are dealing with what? Powers, right? So you can't have negative over here. Let's see, one second. Let me just show you this. Let me write it over here. Let me write this equation: 160 into x to the power minus 0.4 plus 90 divided by 4, multiply it with x to the power minus 0.4 plus 15. Okay, now, okay, that's not correct answer. Don't just put equal. Whatever the previous x value was stored, that will be your answer. Now we will calculate at 0. You're getting an error. Why? Because the denominator will be 0. You will not get an answer. Now let's calc at, so it's negative 0.4. Now calc here, let us put the value of positive one-sided limit from the positive side. That's 0.01. What's happening? You're gonna get 20. Let's increase the digits. Like, let's go more closer. 0.001. It's going to 37. Okay, so let's still go closer because you can see the graph over here. It's varying, and then it goes towards a point. So calc is 0.000001, and you can see it's going to 39. I think so. That's enough. It's going towards 39 or something like that. It's 40. Okay, that's the answer. Now another way would be just solving this over here. What is the, okay, we had learned about a thumb rule. Do you remember? What is this? X, the denominator, the highest degree, it is x to the power minus 0.4. You should divide this by 1 and divide both the places. X to the power minus 0.4. When you divide, what happens? It goes up and it is x to the power 0.4. So therefore you multiply up and down by 0.4. So basically this will be nullified, and then sorry, over here it will remain, okay, with 90 and this. So what happens is this will become 0, 0. You're remaining with 160 by 4, and that's the answer, 40. Okay, or you can do the calculator method. See, when you're increasing the zeros, you will come, looking at the options, you will come to the conclusion that it is 40. Now the same thing, you need to do it for infinity, right? For infinity, let's just change it to a big number. What's the answer? It's 6. The answer is 6. You can do the same thing and you'll find the answer 6. So this is the answer. Now here, whenever you put infinity, because it's 1 by that particular value, right, 0.4, when you tend this towards infinity, what's the answer? It'll be 0. So this and this cancels out. You're remaining with 90 by 15. So this is the answer, 6. So when there is minimum light, it's not about solving this. You can do that in calculator. Understanding, for minimum light it is f of 0, maximum light it is f x tends to infinity. That is very important. Okay, so this is how we can easily solve it up. And okay, now one more thing, minimum light, when you graph exponential, graph this, it starts from 0. Okay, always go from the positive thing, because it's a real world problem. And that's it. That is the end of this lesson. It was a long lesson. I hope you have understood, and if you have any doubts, you can go back to the part and watch it again. Before coming to this lesson, I hope you are thorough with the first 4 lessons, which are already uploaded. Watch them in continuity. This is the last lesson in limits and continuity. Next one will be the new chapter. So please do stay tuned, and I will try to upload it as soon as possible. Happy learning. And if you have not yet subscribed to my channel, I kindly do request you to subscribe. That would mean a lot to me. Thank you guys, and see you in the next video. Bye bye for now.